Today's lesson is 5.5, trigonometric ratios and their inverses. Before we go ahead and learn about our three trig ratios today, we need to learn how to label our right triangles so that we can use one of our trig ratios. So we've been talking quite a bit about how to name the three sides of my right triangle. And let's go ahead and start with the hypotenuse. Remember, the hypotenuse is the longest side, and at neither end of it should I see the 90 degrees. So angle A and angle C are not 90 degrees. Therefore, I know that side AC is the hypotenuse. So let's go ahead and label that. Okay. We've also been talking about how if we grab the 90 degrees in the corner and we draw the two sides that make the 90 degrees, these two are our legs. Now we have to be very specific about which leg we're talking about when we use the trig functions. And they're based off of the angle that we have inside the triangle, how I name the two legs. So if I know angle C, I name them one way, and if I know angle A, I name them another way. One way that you would know it is they would give you a degree. They would put a number inside the triangle right here at angle A, or they could put one right here at angle C. Another way is I could use a variable. One of the variables you could see is called theta. It's a Greek letter. And theta just is like an x value, but for angles. We normally don't see it used in an equation situation. We more than likely see it inside of a triangle or a parallelogram or something like that. But theta is a special x value for angles. Now, to name the other two legs, what you're going to do is you're going to draw your arc mark here at theta, and notice that this side of the arc mark is touching the hypotenuse, and this side is touching the leg. This leg that the arc mark for theta, for your angle, is touching is called the adjacent side, because adjacent means I'm right next to theta. I'm right next to the angle, okay? So then what would I call side AB at the top? Well, I always talk about its relationship to the given angle, in this case, theta. If I take theta and I go straight across the triangle, I hit that last side, AB. Because it is across it like that, I'm going to call it the opposite side because it's opposite theta. Okay? Now, theta can move. Theta is not always going to be down there at angle C. Theta could move over here to angle A. If theta moves to angle A and I do my arc mark, I'm still touching the hypotenuse here. That's not changing. But notice now I'm touching the opposite angle. That cannot happen. That means that these two are going to switch. These two words are going to switch. And so this will become the opposite side, and this would become the adjacent side. Okay? So they are not stagnant. They don't stay there forever like they do in the special right triangles. They can move back and forth. Your theta will never be your 90 degrees. Theta will never be 90 degrees. You can never use the 90-degree angle. You can use the trig functions because you have the 90-degree angle. Okay? That does not mean you use the 90 degrees inside, because what's opposite the 90 degree? The hypotenuse. Okay? So I cannot use trig functions for the degree 90 degrees. I can only use it for the angle here at C or the angle here at A. All right, let's go ahead and take a look at our first trigonometric ratio, which is the sine function. Excuse me. All right, the sine function is written like this. It looks like sin, okay, but we're going to do the sine of theta. So the sine of the angle is equal to the opposite side divided by the hypotenuse. Okay, so based on what my value of sine is, my value of theta is, it depends on what my sine ratio looks like. So let's go ahead and let's look at sine A, the sine of angle A. Here, of course, is angle A, and we could go ahead and call it theta if you want. We could go ahead and put theta right there. If you're going to make your arc mark, notice that here it is touching the hypotenuse. And then here, this must be the adjacent. And then, of course, this last side would be my opposite. Okay, so if I was going to do the sine of A, I would put the opposite. Let's go ahead and just put OPP over the hypotenuse. Let's go ahead and put HYP, height. And I would put the letters B for, no, A, sorry, over C. Whatever the A value is over whatever the C value is. Now, if I were to change that to B, notice now we're going to change this to angle B. Watch what changes. Watch what changes. So now my theta is here. Now my theta is here. Notice when I make my arc mark for this theta, my hypotenuse stays the same, but notice this now becomes the adjacent side, and then the adjacent would become the opposite. Now, this doesn't make a lot of sense, so I'm going to go back and I'm going to use my highlighters. This is adjacent to the purple theta, and this is opposite and adjacent to the pink theta. Okay, the sine function does not change. The sine function does not change. It's still going to be the opposite over the hypotenuse. Okay, so in this case, because we're talking about B, my opposite, or sorry, yeah, we're talking about angle theta being angle B, it's going to be B divided by C. So you're never going to get both of them. You're never going to get both angle A and B. You just have to use one or the other. Let's go ahead and take a look at some examples. All right, here are two examples. And notice that in my triangle, I have three things given, but one of them is an angle. Notice one of them is an angle. This is my theta. This is my theta. Remember, 90 degrees is just saying you can use the trig functions to solve. The other two sides that I'm given are a given side, 30, 35, and then an x value that they're wanting me to find. So I always start by labeling and putting my arc mark at the given theta, which in this case is 80 degrees. Then I go ahead and I want to make sure that I know which one of the two sides I'm touching is the hypotenuse. Well, that would be the 30 because the one at the bottom goes to the 90 degrees. That makes it a leg. That means that this part right here is my adjacent side. I'm going to go ahead and write just ADJ for adjacent. And this is my hypotenuse. Okay? That means my side X is opposite, is the opposite side. Now what I'm going to do is I'm going to cross out the side of the one side of the triangle that is not labeled. So take a look. The hypotenuse is labeled as 30. The opposite side is labeled as x. The adjacent side has no label. I wrote that word, so I'm going to go ahead and cross it out. I have hypotenuse and I have opposite written down. That means I can use the sine function. Okay, that means I can use the sine function. Some people have come up with mnemonic devices to help you remember sine, cosine, and tangent. And the one for sine is SOH. So, S for sine, O for opposite, H for hypotenuse. This is how you can, it's just a way to help you remember. Remember the formula said sine of theta, so I'm going to put sine of 80 degrees equals the opposite over the hypotenuse. Okay, so that's how I'm setting it up. Sine theta equals opposite over hypotenuse. Okay, now I'm going to go ahead and I'm going to solve this. I can think of this as being like a proportion. Okay, so that's one way I could do it. And I could just crisscross multiply. Another way I could think of it as I need to get x by itself. How do I get rid of a division? I multiply by 30. Okay, so either way will work. Either way will work. I'm going to go ahead and just multiply both sides by 30 because it seems to be the quickest way. Now, on this side over here, where x is, notice I have x left. X is completely alone, and I have isolated it. That means I'm going to take this stuff right here, and I'm going to go place it into a calculator. Now, I need to put it in a scientific calculator, and I have found one for you that will really, really help you out. Let me write that down. And we're going to go ahead and take a look at it right now. So we're going to go to the web, and Desmos.com has a scientific calculator that I think is absolutely fabulous. Notice right over here, I want to keep it on the main menu like it has. And right down at the bottom, I can see sine, cosine, tangent. It looks like sin, cos, and tan. Those are my trig ratios. So I'm going to go ahead and type in 30, there we go, times, and then I'm going to put sine, and my degree was 80. And notice I don't even have to press enter. Right over here is my answer, 29.544232259. Let's go ahead and let's go back over to our notes, and let's write that down. 29.544. There's a bunch more numbers. Now, depending on where Alex asks you to round, would depend on what your answer is. If I were to round to the nearest tenth, that would mean that Alex only wants one number after the decimal. So you would find the decimal. Here is the one number after it. And this 4 would say if I kept the 5 a 5 or if I made the 5 a 6. And all these other numbers wouldn't matter. Or Alex is going to ask you to round to the nearest hundredth. If Alex asks you to round to the nearest hundredth, Alex wants 2 decimal places. So you're going to go to the decimal, you're going to count 1, 2. There's the second number. This one's going to help you decide if you leave the 4 a 4 or make it a 5, and all the rest of those numbers in my calculator didn't matter. So if Alex wants to the nearest tenth, I would say 29.5. If Alex wants to the nearest hundredth, I would say 29.54. Okay, there we go. Let's go try the next one. So you're going to mark your angle. You're going to decide which one of those two sides is your hypotenuse. X is going to be my hypotenuse this time. Remember, this side right here would be your adjacent. Since there's nothing there, you're going to go ahead and cross it out. You cannot use it. There's nothing there. And then your third side is, of course, your opposite side. So notice once again, I have my opposite and I have my hypotenuse. I'm going to go ahead and use sine. That's the beauty of so. I can remember that I'm going to use sine. Here is my formula right here. Let's go ahead and plug everything in. The sine of 42 degrees equals the opposite, 35, over the hypotenuse x. Now, in this case, the number and the x value have switched. So what I'm going to go ahead and do is I'm going to solve this the same way. I am going to go ahead and multiply this side by x, and I'm going to multiply this side by x. These x's would cancel out, and over here on the right side, I'm left with 35. On the other side, I have x times the sine of 42 degrees. Is x alone? No. What's bothering the x? Well, actually, all of this is bothering the x. If I were to go into Desmos to show you right now, sine 42 is a decimal. In fact, let's go ahead and look. Let's go ahead and clear this, and let's put in sine of 42. Notice that Desmos is giving me a decimal, okay? 42 and sine of 42 are both numbers, okay? 42 and sine of 42 degrees are two totally different numbers, though, and you just saw that. So how do I get rid of this number, which is 0.6 something? Well, I'm going to get rid of the multiplication. And to do that, I'm simply going to divide by the same number. Right? If I divide the sine of 42 by the sine of 42, they cancel out. What I do to one side of an equation, I must do to the other. Now what I can do is I can go ahead and I can go over to my calculator and I can put this in that scientific calculator. Last time we pressed 30 times the sine. This time we're going to do 35 divided by the sine. Let's go ahead and take a look. 35 divided by sine 42. 52.306. 52.306. 52.306. I think there was another 6. All right, so remember, if Alex wants you to round to the nearest tenth, that means one decimal. You're going to find the decimal, count out one number after it. This one's going to decide, should I keep it a 3 or make it a 4? If Alex says to the nearest hundredth, you're going to put your decimal here, and Alex wants 1, 2 numbers after it. So find your decimal, count 1, 2. There's the one Alex wants. This 6 is going to say if I make the 0 a 1 or if I keep the 0 a 0, and these ones don't matter. If I was rounding to the nearest tenth, I would keep it as 52.3. So nearest tenth, 52.3. That 2 was kind of wonky. If I was rounding to the nearest hundredth, though, because the 6 is after the 0 would become a 1 because 6 is 5 or more. I'm going to go ahead and add one more and count it 52.31. Okay. I can also use my sine function's inverse to help me find my value of theta. Take a look at these. I'm still going to use the concept of sine theta being the opposite divided by the hypotenuse. I'm still going to use that idea. But this time, when I mark theta, notice that theta is the variable. This is still my hypotenuse. And this is still my adjacent because that still works. My adjacent is not labeled, so I'm going to go ahead and cross it out. And of course, this is my opposite side. So what would I do here? I would say sine of theta, which is x degrees, equals the opposite 12 over the hypotenuse 17. I'm going to go put this into Desmos, into the calculator, and to do this, I am going to use the inverse of sine. And when that opens up a parentheses in the calculator, I'm going to put my opposite over my hypotenuse. And this is going to give me x. So to find x and how many degrees it is, I'm going to use the inverse function. Okay, so let's go over to Desmos and let's clear this. Oh, let's see. I don't see it. Uh-oh. Uh-oh. Oh, shoot. I'm not seeing it. Oh, there it is. So I went ahead from the main. I hit this one that says func. I'm guessing it's function. Take a look right here. Right under sine, where it looks like sin, is the sine inverse to the -1. So I'm going to press that button, and then I'm going to go back to the main because I need to go ahead and put in that fraction. Notice up underneath that little wrench, there's the A divided by B, right, by the percent. I'm going to go ahead and click on that, and this is where I can go ahead and put in, oh, what was it, 12 divided by 17? I forgot. Oops. Yes, 12 divided by 17. Oops. Function, sine inverse, go back to the main, A divided by B, 12, 17. And there's my answer, 44.900. So I would go ahead and we're going to say 49.1 degrees. Let's try it one more time. So you're going to go ahead and mark. This will be the hypotenuse. This is going to be the adjacent. Now, I know you're probably sitting there thinking, Miss, if we're not using it, why are you marking it? Well, because you're just learning sine right now. When you go to do your assignment, you've got to decide, is it sine, is it cosine, is it tangent? And so you got to make sure that you mark all three sides as opposite, adjacent, and hypotenuse so that you could see which one you use. I have O and H, hypotenuse and an opposite, so I'm going to go ahead and use sine. Sine of x degrees equals the opposite, 3 over the hypotenuse, 7. 3 over 7. So I'm going to go put in my calculator to find x, the sine inverse 3 divided by 7. That's what I'm going to go put into the calculator. All right, so let's clear it all. Let's go to the function, hit sine inverse, go back to the main menu, hit your A over B, 3 over 7. 25.37. The 7 after the 3 would go ahead and make it a 4, and so I'm going to say 25.4. 25.4 degrees. All right, our second function, trig function, is our cosine function. And to use the cosine function, it is cosine of theta it looks like cos, equals the adjacent over the hypotenuse. Adjacent over hypotenuse. So just like sine, it matters where theta's placed. It matters where theta's placed. So if I place theta here at A, let's go ahead and make it pink. This, of course, is my hypotenuse. And I hope you're going to start to notice that the hypotenuse does not change. This is going to be my adjacent because it's next to my theta. And of course, this side over here at A is going to be my opposite. To find cosine, it's adjacent, which would be B, over the hypotenuse, which is going to be C. If I were to go ahead and switch that theta up here to B, if I switch my theta up here to B, my hypotenuse does not change. So notice the hypotenuse is not changing. It's never going to change because the hypotenuse is the hypotenuse. But remember, this side is now going to be my adjacent, and then what was my adjacent is going to become my opposite. So this is for my purple, and this one's for my pink theta. It just depends on where theta is. Now, this is not going to change. Oops. This is not going to change. It's still adjacent over hypotenuse, but the actual letters are going to change. It's going to be A over C. All right, let's go ahead and take a look at this. Now, the way that you can remember cosine, what people use is C for cosine, A for adjacent, and H for hypotenuse. K is how we say it. K. So if we put the two together, we have so K. And then tangent is going to make another word, and so we could kind of remember the little rhyme. So K, and then we'll learn the one for tangent in just a moment. All right, so very, very similar, very, very similar. Remember, we want cosine, oops, there we go. Cosine theta equals adjacent divided by the hypotenuse. That's my formula. So same thing, grab your theta 32, grab your theta 35. You always want to mark your theta. Decide which one is the hypotenuse. Here is my hypotenuse. The other side, the other one that the arc is touching, remember, is your adjacent. And of course, your third side over here is your opposite. There is nothing at the opposite. There's no x, that's with adjacent. The 25 is with the hypotenuse. So we're going to cross out the opposite in this case. Same thing with the other one, but we'll get to it in just a moment. Now we can go ahead and we can put this into the formula. So cosine of 32 degrees, because remember theta is always the degree, equals the adjacent x over the hypotenuse 25. Just like before, we're going to go ahead and multiply by whatever's in the bottom of our fraction because that's going to eliminate it. And notice that my x is alone, so I'm going to go ahead and put this in my calculator. 25 times cosine 32. 25 times cosine, oops, nope, I didn't get the 5. 25 times cosine 32. 21.2 or 21.20, depending on what Alex wants you to round to. I'm going to go ahead and just put 21.2. Okay, that one was pretty easy. I just went ahead and put it in my calculator. Let's take a look at the other one. X would go ahead and be my hypotenuse. 30 would be my adjacent. And of course, my opposite side is blank, so I'm going to cross it out. So notice I have A and I have H. I'm thinking I'm going to use cosine, cosine. Okay, so cosine 35 degrees equals adjacent 30 over hypotenuse x. I multiply by whatever's in the bottom of my fraction, both sides. This time though, the x is not alone. I have that cosine of 35 sticking around. This is a number just like the sine was a number. So to get rid of this, you're going to go ahead and divide by the cosine of 35. They're going to cancel out, and what you do to one side, you must do to the other. Okay, now I'm going to go ahead and I'm going to go over to my calculator and I'm going to place this in my calculator. So let me show you that. And it's 30 divided by cosine 35. 36.623, so 36.6 to the nearest tenth, 36.62 to the nearest hundredth. Let's go ahead and just put 36.6. I can use the inverse of the cosine function to help me find the degree of the angle. So that's what we're going to go ahead and do next. Remember, the cosine function was adjacent over hypotenuse. This time though, when I go ahead and I mark x, notice that when I go ahead and mark theta, it is x. So this is where I know that I'm going to use my inverse function. This is how I know I use the inverse. So there's my hypotenuse. Here is my adjacent. They are both marked. My opposite side is not marked, so I cannot use it. Once again, because I'm crossing out opposite, it rules out sine. It rules out the use of sine. I cannot use sine because sine has the opposite. I can use A and H, which is cosine. So that's the reason that I keep writing the opposite as well. All right, I'm going to go ahead and I'm going to plug them into the formula. So when I plug them in, I see cosine of x degrees equals adjacent 20 divided by hypotenuse 38. When I see this, that x is next to the trig function, this is where I use my inverse trig function, and my fraction that I create is the adjacent over the hypotenuse. This is going to go straight into the calculator and it's going to give me my answer. So 20 divided by 38. 20, 38. 58.2 or 58.24. Let's try it one more time. So you're going to want to mark it. This would be my adjacent. Just spicing things up a little bit here. Here would be my hypotenuse because 9 does not have the 90 degrees. And of course, this side, which I'm not using, is my opposite. I'm crossing it out so that I know to use cosine. Cosine of theta equals adjacent over hypotenuse. Since the cosine is the x value, since the x is next to cosine, I'm going to use its inverse, and I'm going to put cosine to the -1, 5 divided by 9 in my calculator. 5 divided by 9. Cosine, fraction, 5 divided by 9. 56, oh, 56.25 or 56.3. Ooh, that one was tricky. 56.3 degrees. My last trig ratio is the tangent function. My last trig ratio is the tangent function, and I call it tan. The function is the tangent of theta is equal to the opposite over the adjacent. Notice what's missing. Hypotenuse. There's no hypotenuse for the tangent. Let's go ahead and put my theta here at A. If I do my arc mark, here is my hypotenuse. Here is my adjacent. And here is my opposite. So my tangent would be the opposite, A, divided by the adjacent, B. If I were to go ahead and switch my theta up here to angle B, my hypotenuse is not going to change, but my opposite will now become my adjacent, and my adjacent will now become my opposite. Remember, this is for the purple, these are for the pink. All right, but that doesn't change my answer over here. It's still the opposite, but with purple, that's B, and it's still over the adjacent, but with the purple, that's A. Notice that these two are reciprocals of each other because they flipped, okay? The tangent's the only one that does that. They are the reciprocals of one another. All right, let's go ahead and take our practice problems. So here we are. Let's go ahead and write down the formula because it's on the other page. So tangent of theta equals opposite over adjacent. All right, mark, 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 mark. That's like the best thing that I can tell you to do. Here is your hypotenuse. Notice it is not labeled, so you do not need it because you're not going to use it. Here is your adjacent. Okay, you just need to mark them, and you just got to decide which one's the hypotenuse. Remember, it doesn't have the 90 degrees. The other one's the adjacent. The third side is going to be your opposite. Here is how people memorize tangent. Here's how we memorize tangent. I'm just trying to pick a good color to go with my purple and pink. Oh, why not this orange? T for tangent, O for opposite, A for adjacent. TOA is how we call it. So if you put them all together, it's SOHCAHTOA. SOHCAHTOA. All right, let's go ahead and do the actual problem. So I'm going to go ahead and choose tangent for this one. Tangent of theta, theta is 32 degrees, equals the opposite x over the adjacent 12. I'm going to go ahead and multiply both sides by 12. And I'm going to go ahead and put this right into my calculator. And I think you guys kind of got the hang of the calculator. So I'm just going to go ahead and tell you that I went ahead and got 7.5 for this one. Let's go ahead and take a look at the next one. I label it right here. This would be my hypotenuse, but since it is not labeled, I'm not going to use it. And this is my dead giveaway that I'm going to use tangent, TOA, because it does not contain that that hypotenuse. This would be my adjacent side, and of course, this would be my opposite side. So because I have A and O, because I have A and O, I can only use tangent because TOA is the only one with A and O in it. And of course, remember T stands for tangent. Let's go ahead and plug it in. So tangent of theta, which is 43 degrees, equals opposite 17 over adjacent x. I multiply what's in the denominator to both sides. I cannot actually put this in the calculator quite yet. Just like with the sine and cosine, I'm going to have to go ahead and get rid of this by dividing by the tangent of 43 degrees. It's going to completely cancel out, and what I do to one side, I have to do to the other. And once again, I know you guys got the hang of that calculator, so if I were to put this in the calculator, I would get 18.2. I can also use the inverse function of the tangent to help me find my degree of my angle theta. So here is my tangent trig ratio. One more time, opposite over adjacent. But this time when I mark theta, notice theta is x. So here is my hypotenuse, which of course I'm not going to use because it is not marked. Here is my adjacent. It is marked as 12. And here is my opposite. It is marked as 5. I'm going to go ahead and put in my x, my 12, and my 5 into this function. Tangent of x degrees equals opposite 5 divided by adjacent 12. Whenever I see x right next to the trig function, sine, cosine, or tangent, I'm going to go straight to my calculator and I'm going to use the inverse function, and I'm going to simply put in the fraction that I created on the other side. Now I do have to go use my calculator for this one because I don't have this one done. So tangent inverse 5 over 12. 22.6. 22.6. And of course it would be degrees. Last one, yay! Here would be my adjacent because it has the 90 degrees. Here would be my hypotenuse, which I am not going to use because it is not marked. And here would be my opposite. So once again, I'm choosing tangent because I see O and A, and because they're the only ones that have O and A. So I'm going to go ahead and use tangent. Tangent of theta, which is x, equals opposite 9 over adjacent 2. Because my x is next to the trig function, I'm going to use the inverse, 9 divided by 2. And once again, I've got to go back to my calculator because I don't have this one saved. 9, and the bottom is 2. 77 point, the 4 would round to a 5 because of the 7 right after it, 77.5. 77.5.